For a 125 amp subpanel, a grounding electrode conductor or GEC is sized according to Table 250.122 C of the National Electrical Code. For a 130-foot run of 2-inch polyvinyl chloride conduit buried 18 inches deep, you'll need a 4 American wire gauge copper wire or larger for the GEC. The subpanel size should be based on the total amperage of all the circuits connected. The total amperage in this scenario is determined by firstly, 50 amp welder outlets, 4 outlets times 50 amps equals 200 amps. Secondly, an air compressor rated at 20 amps. Thirdly, 20 amp outlets, 2 outlets times 20 amps equals 40 amps. Fourthly, a garage door opener and exterior light using 15 amps. Fifthly, fluorescent lights utilizing 3 times 15 amps equals 45 amps. The total calculated is 320 amps. Therefore, a 125 amp subpanel at a minimum is required. The ampacity of the breakers in the subpanel should not exceed the ampacity of the main breaker in the main service panel. In this case, the main breaker is 200 amps, so all breakers in the subpanel must be rated for 125 amps or less. Multiple wires can be run off a breaker, but the total amperage of all the wires combined cannot exceed the ampacity of the breaker. For example, the 50 amp breaker feeding the welder outlets can have multiple wires connected to it, as long as the total amperage does not exceed 50 amps. Other considerations include conduit fill. Ensure the conduit is large enough to accommodate all the wires without exceeding the conduit fill limit specified in Table 392.10 B3 of the NEC. Also, calculate the voltage drop for each circuit to ensure it is within acceptable limits. It's imperative that all electrical equipment is properly grounded and bonded according to the NEC. Contact the local electrical inspector to obtain necessary permits and schedule inspections throughout the project. Always have the schematic reviewed by a qualified electrician before starting any installation.